Morning. We are going to continue from where we stopped. I said that we are going to start discussing the comparative static. Now, when we look at comparative static, is one of the most important processes that normally use the mathematics of chain rule to actually make inferences on a number of situations. For example, looking at the chain rule, we can be able to define a function to say when z is equal to capital F xy with x is equal to ft and again y is equal to gt, like this one, then we can actually find dz dt is equal to f prime x comma y d x d t plus f prime 2 xy and then dy dt. So this is actually the general formula that can be used to define the situation. So this one is just a function. This one is just the function. This one is just the function, and this one is the function. So if I put 1 here, it means that I will be differentiating x, and if I put 2 there, it means that I'll be differentiating y, and then after that I'll be taking what is dy, what is dt, and here I will take what is dx, what is dt. So I want us to understand the formula properly so that we can actually check how it goes. So it's a multivariable. Okay, it's a multiple variable expression computation. So it is a multiple variable expression computation. For example, let's say we should have like an example to say compute dz dt for a function when z is equal to fx and is equal to x squared plus y squared when on the other part x is equal to t squared and at the same time y is equal to 2t. So looking at this statement, we can be able to actually use this particular equation which we have drawn here. So what I can say is from this particular statement, we can be able to determine the value. So I want you to check. If I say f prime f1 prime xy, it means that I'm differentiating in this expression. I should only look at differentiating x. So since the expression is x squared plus y squared, then I should be able to have 2x because this one cancels. It is assumed to be a constant. So if I say f prime 2xy, in this case, I should be able to get again 2y because the x normally it vanishes. So it will be 3y, sorry, because here is a 3. So it's a 3y. Then the other part vanishes. And then I should be able to look at what is my dx dt. What is my dx dt? So if you can say this is x is equal to this, and this is y is equal to that. So if you take dx dt, then the answer is 2t. And if you say dy dt, again the answer is 2. So in this case, using the formula dz over dt is equal to f prime xy dx dt plus f prime 2 xy plus dy dt. Once we do that, we can be able to actually have the expression which is now equal to 2x multiplied by 2t plus 3y squared multiplied by 2. So that at the end of the day, we actually have got now the value which is equal to 4xt plus 6y squared, which is uh, which is which is equal to that. So at the end of the day now, we can be able to now take like some parts. So this is going to be the answer. So it's dz dt is equal to this is the situation. So that's the most important part which we can look at. Now these processes we actually call it the chain rule process. So I want you to understand it properly. And on the other part, we have got another statement which can say find dz dt if and only if z is equal to xe to y and x is equal to root of t and at the same time y is equal to natural log of t. So if we have got something like that, then I should be able to look at what is that. Then I should be able to look at from this particular expression. If I take f prime x, the answer is equal to 2 because I'm only integrating this. So the answer is going to be equal to this one. But if I now take f2 prime xy, in this case, so it means that I should be able to look at that. So the answer is going to be equal to 2x e to y. Okay, now if I now take what about dx dt? Dx dt is now this one. So dx dt, in that case, it is going to be equal to half square root of t, and then dy dt, which is equal to this one, is equal to 1 over t. 1 over t, because that's the integral. Then thereafter, you can be able now to rewrite them in the formula f prime xy, okay, dx dt plus f prime 2 xy multiplied by dy dt. So you can be able to actually take them into that particular part so that it can substantiate that. So you just take now these values and realign them in this particular equation. So this is how we normally can be able to take these statements to be in that particular order. Now let's look at further application of these statements so that we can be able to appreciate more on that. Sometimes this chain rule, it can be applicable in a Cobb-Douglas. It can actually solve a Cobb-Douglas situation, which I will be able to give you in the next section, because we wanted now to have more time so that when recording we shouldn't have some challenges because the time is actually perceived to be significant, because we can actually record things that at the end of the day we can actually find things that are that could be very difficult to actually record. So we are continuing in the next section.